Hello. So for our initial Heidi Weinberg population here, we're going to have these special crabs we're going to be looking at. So we have our homozygous recessive crab, which will be our white, our homozygous dominant crab, which will end up being black, and our homozygous or heterozygote, which will be a mix and speckled. So you can see by the frequency and the amount of speckled heterozygotes that is actually most selected for, because the beach on this island has a lot of like pebbles and stuff, so they're better able to blend in and reproduce and pass on their genes. So to get our allele frequency, we need the total number of alleles to start off. So if we have 500 organisms with 2 alleles each, that'll be 1,000 alleles total. And since each category is going to be multiplied by 2 here, we'll have 470 speckled alleles, 150 white alleles, and 190 in the black category. So to get this frequency of our dominant or P allele, we're going to need the total number. So if there's 190 organisms with each allele being our dominant, that's going to be 380 because it's 190 times 2. And we're going to need to add, so this is only half dominant. So if you multiply that by 2, it's 470, but half is 235. So that'll equal 615. Divide that by 1,000 because the total number of alleles, you get 0.615 in our P value. To get Q, or that lowercase or recessive, we need to take our 1 minus what we got for P, which will be 0.385, which will be our Q. Hello. Welcome back to our island. As you can see, our soil or sand has changed from a volcanic eruption. So as you can see, this darker sand might select for these black crabs more often. So we see here our initial genotype frequencies, and we got that from using our P and Q values. So this would be P squared, 2PQ, and Q squared. So for this value, you take 0.35 and square it. So we need this W to determine that next generation of frequency. So we need that average fitness value, which is W. So we need to multiply our frequency times our new fitness, which you can see is like such. And this, our white crab, has the lowest fitness because it's easy to spot by predators. So multiply this value times this, and then so forth. So for these two, it's 0.037. For this, it's about 0.236, excuse me. And this is about 0.366. And then you add those up to get that average fitness value. So it's about 0.64 for that W. And you divide each of them by 0.64 to get that frequency for each respective phenotype. So this one's 0.57, this one's 0.368, and this one's 0.057. And to get those P and Q values, you need to take the square root of that and square root of that. So this would be our P value, which is 0.755 about, and this will be about 0.239. And this breaks Heidi Weinberg equilibrium because our genetic frequencies changed from the previous generation.